Welcome back, Pre-Algebra. We're in lesson 120. We're going to talk a little bit about volume and surface area for a different set of shapes. Now, we're going to talk about the pyramids and cones and spheres. Note that the triangular pyramid has a base that's a triangle. That's why it's called a triangular pyramid. A rectangular pyramid has a base that is a rectangle. So it stands to reason that if you have an octagonal pyramid, you'd have a base that's an octagon, so forth and so on. But the difference between a pyramid and a cone is that a pyramid has flat sides. And a cone, the base is a circle. So those are the two different, or the main difference between a pyramid and a cone, and that is the shape of its base. If the shape of the base is a polygon, it's a pyramid. If it is a circle, it is a cone. So that's something worth noting or putting in your notes. And we know that a sphere is like a ball. It's a three-dimensional circle, basically. So that means that the radius of the circle, 2 times the radius is the diameter, but that the diameter of the circle is also the height, or the diameter of the sphere is also the height of the sphere, because the radius radiates from the center in every direction, covering every point three-dimensionally. So not only is the diameter of the sphere 2 times the radius, but the height of the sphere is 2 times the radius, and the width of the sphere is 2 times the radius, or the same as the diameter. There are formulas for volumes of cones, pyramids, and spheres, but formulas are kind of hard to learn and easy to forget. So it's a little bit easier to find the volumes once you visualize what you're doing. So I'm going to draw a few lines here just to kind of show you what we're doing. So this is not very straight. Let's let it straighten out. All right. So here is kind of the top. This is one side. If I were to come straight up and down, see if I can get this a little bit better right here. From the corners straight up, I would make the pyramid just like that. And then I would come from point to point over here. Let me see if I can line that up a little bit better. All right, so you can see if I were to come straight up from the base, that the cone, or the pyramid takes up only a part of that. And we know, based on mathematical calculations over and over again, that a pyramid takes up exactly 1/3 of the space that the right solid shape of the base would take. So what that means is the volume, I'm going to give you the formula here, the volume of a pyramid is equal to 1/3 of the base area times the height, which is how you would calculate the volume of the right solid. You would find the base area, and then you'd multiply that times the height. You can also rewrite this much easier, and it makes sense if you think about it. Remember, a triangle is 1/2 the base times the height because it's a 2-dimensional shape. Well, this is a 3-dimensional shape, so the pyramid is going to be 1/3 the base area times the height, and that's your formula for the volume of any type of pyramid, whether it is triangular or rectangular or octagonal. We know mathematically that it is 1/3 of the shape. And the same is true for a cone. If I were to draw a semi-straight line here and a straight line here, we could envision the cone being a right circular cylinder, right? This is the top and this is the base. The cone is the same formula. We know it is exactly 1/3 of the volume of a right circular cylinder of the same shape base and the same size base. So the volume for a cone is exactly the same thing. The volume formula is going to be the base area times the height divided by 3, or 1/3 of the base times the height. So these are really easy to calculate if you can remember or correlate that this is a three-dimensional shape, so you divide it by 3. That really helps me to remember it. Find the area of the base, multiply it times the height, remember that's a three-dimensional shape, and divide it by 3. And that will help you find that for both the pyramid and a cone. The sphere is a little bit different because we have two halves here. That's how you have to think of it. But the sphere also uses the right circular cylinder in order to calculate. But it is just a little bit different. Let me move this over a bit so that it's more in line with the side here. And I'll finish my little example drawing. So we've got our top and we've got our full circle here, but we've also got the full circle, which I'm not very good at drawing, obviously. We've got that full circular base as well. And my pen just does not want to stop where I want it to stop. It keeps messing up. I'm going to go a bit slower. See if that makes a difference here. And then this would go back here and meet around. So the slice of the sphere that makes this full circle here, that would be the same as the base here and the same as the top here. So it is also related to the cone in that it is a right circular cylinder, but it takes up more of the volume than the cone does. So the volume for a sphere is going to be 2/3 of the base times the height. So you find the base or the center circle, and we are going to multiply 2 times the base times the height, but then we're going to divide it by 3. And if it helps you to remember, this is what helps me to remember the formula, is that there's 2 halves to the sphere. There's 2 identical halves, and it is a three-dimensional object. So 2 times the base times the height divided by 3. 2 halves of the sphere, indicated by this little hemisphere line right here. This is the base, and it goes this direction, and it goes this direction. So it goes in 2 different directions. So it has 2 halves, right? But it is a three-dimensional shape, so we divide it by 3. That's kind of what helps me remember the formula for the volume of a sphere. But if you will, I'm going to move this over a little bit. If you will, kind of think of it in those terms. Little things like that help me remember those volumes and those formulas. So try to use little tricks and like little things that you can hang the remembrance of the numbers on. But if you notice, the base volume, the base of all of these is base times height. If you can remember base times height and just the little things that go with it, right, then that will help you to remember the formula. All right, so let's try an example problem. We are going to do example 120.1. So let me put that up here for us. All right, so here we have a right triangular prism. And that just means that it is centered. It's straight up and down. It's not skewed in any kind of way. And we have the base here. So we have to find the base area and multiply that times the height and then divide that by 3 in order to find the volume of this pyramid. So we're given the base here, which is this right here. This side is 6 meters, and this side is 3 meters. And the height is 4 meters. But we just have an illustration here so you can see what this is sitting on top of. All right, so first we're going to find the area of the base. We know the area of a triangle equals the base times the height divided by 2. So that's going to equal 6 times 3 divided by 2. that's going to be 18 divided by 2, so 9 meters square. That is where we are right now. So now we're going to take this area of the base, and this is area of the base, by the way, or base area, however you want to say it. And we're going to put that into this formula. So now our volume of this pyramid is going to equal 9 meters squared, and we have a height of 4 meters, so times 4 meters, it's M, over 3. We're going to divide that by 3. 9 times 4 is 36. 36 divided by 3 is going to equal 12 meters cubed. You could see this is not a whole lot of math. Not a whole lot of math at all. It's just simple multiplication and division. You just have to remember where to put what in and in what order it occurs. So area is 2 dimensions, volume is 3 dimensions, and that helps me remember what to put where when it comes to the formula. All right, we got to find area first and sub it in for the base, multiply that times the height, and don't get confused on area, these two heights. You could actually, I know it's base times height, but you could actually call that base, or you could call that length times width, if that makes you feel better. It's just these 2 dimensions times this dimension divided by 3, because you've got 3 dimensions. And if it makes you a little bit, or if it makes it a little bit easier to solve it, you could do it all at once. You could actually say volume is equal to length times width divided by 2, right? Times height, all of that divided by 3. That's what you're doing ultimately. That is your formula for the volume of a pyramid. That's exactly what we did. We just did it in multiple steps. But if you were to say 6 times 3 divided by 2 is 18 divided by 2, that's going to be 9 times 4, 36 divided by 3. It's the same answer. It's the same answer. It's just a 2-step problem. And this is what you're subbing in for B. Length times width, right here. The base times the height. And then again, base times the height. All right? Okay. If it makes you feel better, just call this area times height. That might make it an easier problem for you to solve, calling that area times height. I just want to be clear which numbers you're using when you do your calculations. All right, let's move on. Let's do problem 120.2, where we're going to find the volume of a cone. Okay, so let me put that up here for us. All right, in problem 120.2, we're going to find the volume of this right cone. And we're told that the radius of this cone is 10 centimeters and the height is 4. So first we need to find the base area, because we need to find the base area in order to calculate volume. So the base area of this is going to be a circle. So we're going to find the area of the circle. And the way we find the area of a circle is pi r squared. So we're going to say pi times the radius of 10 times the radius of 10. Right? So that is going to equal 100 pi centimeters squared. Excuse me. So there's our base area right there. So we're going to sub that in here. That's going to be the base area. So the volume is going to be equal to 100 pi centimeters squared times the height, which is 4 centimeters, over 3. So when we do the calculation, we get 400 pi centimeters cubed divided by 3. And what we can do is we can just go in here to our calculator and we can say 400 divided by 3 is equal to 133.33333. So we have a repeating decimal. If we wanted to, we can multiply that times pi. We still get a repeating decimal. So it doesn't really matter. Let's just there we go. So 133 with a repeating decimal of 3. So let's write that. 133 with a repeating decimal times pi centimeters cubed. That is the volume of this cone. Okay. Now, when we have something like this, and you cannot use the repeating decimal symbol within our system, if it doesn't let you do that, just write the decimal twice. Okay, whatever the repeating pattern is, the repeating decimal, write it 2 times, and it will be graded correctly from there. So that will give me the understanding that this is a repeating decimal. I'm perfectly fine with that. That works. All right. So let's move on and let's do the volume of a sphere in the next problem. Let me put that up there for us. So our next problem is the volume of a sphere, and the volume is going to be 2/3 the base times the height, which is 2 times the base times the height divided by 3. You can write it either way you want. So the first thing we have to do is find the base. So the base is going to be the centermost slice of the diameter of your circle, right? And we calculate that the same way we would any other circle. We take our radius and we have area of a circle is equal to pi times radius squared. So in this case, we have a 10 centimeter radius. It's going to be pi times 10 centimeters times 10 centimeters. So our area of the circle, our base, is going to be 100 pi centimeters squared. That's our base. Now the height is going to be the same thing as the diameter. So if a radius is 10, we know that the diameter equals 2 times the radius. So 2 times 10, the diameter is going to be 20 centimeters, because we have a radius of 10 this way and a radius of 10 this way. So that is the height. It's 20 centimeters. So we're going to take the area and we're going to say 2 times 100 centimeters, or 100 pi centimeters squared, times the diameter, which is the height. That'd be 20 centimeters. And then we'll divide that whole thing by 3. So we'll do this bit first. All we're going to do is just add a 0 here and multiply this times 2. So 2 times 2000 pi centimeters. And now it's going to be cubed because we have centimeters times centimeters. 2 and the 1 together make a 3 over 3. And then we're going to multiply these two. So it's going to be 4,000 pi centimeters cubed divided by 3. What do you want to bet we get a repeating decimal with this one? I think that we will. So let's look it up on our calculator. We're going to say 4,000 divided by 3. Yeah, so now we have 1,333.33, just to signify that this is a repeating decimal, and that's going to be times pi centimeters cubed. And that is the answer for the volume of this sphere, right? So if you cannot make the little repeating symbol, just write the repeating decimal twice, and I will know that that's what that is. All right. So let's see. Now let's talk about the surface area of pyramids and cones. So let me clear the page and put that up for us. So when we talk about the surface area of a pyramid, let me pull a pyramid up and show you exactly what I mean. Let me get a nice one for you. Here's a good pyramid. Pull that out. We'll look at it. So here's a pyramid. Let's look at that. So we can see the difference between the pyramid and the cone is that the pyramid has flat surfaces. This is a flat surface. This is a flat surface. All of these are flat surfaces. So all we have to do is calculate the area of the base, right? So the area of the base. And then we have to calculate each side or each face of the pyramid using, and in this case, it's going to be triangles. So we'll have side 1, side 2, side 3, side 4, side 5. So the area of the sides, right? And then we'll add those two together. If this is X and this is Y, we add those together and we get our total surface area. So that's not very hard to calculate. We just have to figure out the sides and how to calculate those. And that's going to be based on the edge here, the height of each one, and then the base. So for a triangle, we would say the base times the height of each side divided by 2. And then we would add those all together. Not a huge calculation. But let me erase all of this. I'm going to get rid of this one and erase this for us because we need to think about the fact that a cone does not have sides. It's a circle. So how do we calculate that? Well, we have to take into account a new measurement that we haven't used before, and that is slant height. And that's going to be represented by this variable L right here. This lowercase l is the variable that is used in formulas to recognize the slant height. And the slant height is going to be based upon the height and the radius of your circle or of your cone. So this is like the hypotenuse of a right triangle. Remember, we've already done that. So you would have h squared times r squared would equal your slant height. And that's how we would find L. But it is part of the calculation because the degree of angle here, the length here, has a definite impact on your surface area, depending on how steep or how sloped, meaning, a low steepness, that this is. So that is directly related to the height and the radius of your base and your cone. So the L in the formula is the slant height of the cone, and the slant height is just the hypotenuse of the right triangle that we've already discussed. So we could easily find this measurement by using Pythagorean's theorem. So let's look at the lateral surface area of a right circular cone formula. And the lateral surface area, I'm just going to say lat surface area, is going to be pi times r times the slant height, or the hypotenuse of that right triangle. All right, and that is how you would calculate the surface area all the way around the cone. To get the total surface area, you would add in the area of the base, which is a circle, which would be pi r squared. So you'd have the lateral surface area plus pi r squared to get the total surface area. So total surface area is going to be pi r times the lateral slant height plus the base, which is going to be pi r squared. Okay, so you'd have this calculation and this calculation added together to get the total surface area of a cone. So let's practice that. I'm going to skip and do 120.5, and then we'll come back to the surface area of a pyramid next. So we have the cone here, and the radius of the cone is going to be 5 meters. And the, the slant height, L, is going to be 6 meters. All right. So the radius is 5 meters and the slant height L is 6 meters. We don't know what the actual height is, but we don't really need it just yet, do we? Not for surface area, not when we have the slant height, because we don't use height in any of these calculations. So first we're going to find this bit, which is the the cone surface area, the lateral surface area around the top of the cone. So we're going to say the lateral surface area is equal to pi times the radius, which is 5 meters, times the slant height, which is 6 meters. So the lateral surface area is equal to 30 pi meters squared. So that's all of this around the top is 30 pi meters squared. Now we're going to add that to the base, which is just this right here, pi r squared, and the radius is 5, so 5 times 5, I wrote a cube right here, and I do not know why. Losing my mind. That's squared. So that is going to be pi r squared, so that's 25, so plus, actually, let's do this separately, just so you keep it straight. The area of the base is equal to pi times 5 meters times 5 meters. All right, so that's going to equal 25 pi meters squared. Now we can add these two together. So right here, our lateral surface area is 30 pi meters squared plus the base area, which was 25 pi meters squared. And look, they have the same variables, pi meter square, so that means we can add the coefficients together because they are like terms. So that is going to be 55 pi meters square. And that is the answer for the total surface area of this cone, right? Figure out your lateral surface area and then the area of the base, add them together, and that is going to be the answer to your problem. And that is the total surface area. All right, so if we had to find let me erase this. If we had to find the lateral slant height, or the slant height to this cone, and let's say we had a height of 4 and a radius of 3, we could use Pythagoras' theorem to find the slant height, which is the hypotenuse. So we would say 4 squared plus 3 squared is equal to L squared. So that would be 16 plus 9 is equal to L squared. That would be 25 is equal to L squared. And we know when we take the square root of both of these, this cancels. And the square root of 25 is 5. So 5 would equal the slant height. And that is how you would find the slant height of a cone, by using Pythagoras' theorem. Okay? So do not forget about that. We learned that for a reason. And this is one of those. So let's move on, and now we're going to do the surface area of a pyramid, and it's actually easier than this. So let me put that up here for us. All right, for this pyramid, we have been given the base, and we have been given the face of each side. So we have here a square. When we have a square as the base, it makes it so much easier to solve for the surface area of a pyramid, because if we have a square, then that means that all the faces are the same. So we only have to calculate one face and then multiply it by 4. So that's what we're going to do. We're going to think about it, and we're going to say the base first. So the base of the square, we know how to calculate the area of a square. This could be 4, and this is in meters. 4 meters times 4 meters is equal to 16 meters square. And we have the face, which is just a triangle. We know how to calculate that. We know it's going to be height times the base. So it's going to be 3 meters times 4 meters. And then we're going to divide that by 2. and that is going to be 12 divided by 2, so it's going to be 6 meters squared. And we know we have 4 of those, so we're going to multiply that times 4, right? One side, 2 side, 3 side, 4 side, and they're all identical because the length and the width are the same because it's a square. So we can multiply it by 4, and 4 times 6 is 24, so 24 meters squared. So we just add the base to the lateral surface area. It's going to be 16 meters squared, right? We just took this and brought it down here. And that's going to be 0. That's going to be 40 meters squared. Easy peasy, right? We just added these together. We took this and we brought it down and added it to our surface area. So this was our lateral surface area, and this was our base. Isn't that easy? Now, if you have a rectangle, right? Let's say that your base is a rectangle like this. If I can ever get this to actually draw what I want it to. If your base is a rectangle, then you're going to have, let's say this side and this side are the same, and then let's say this is 7 and 7, then you would have 2 sides that you have to multiply by 2. You figure out this side, you multiply it by 2. You figure out this side, you multiply it by 2. You add them together, and then you add that to the base. Right, so you just calculate the surface area of each side, and if there's a way for you to multiply so you don't have to add a lot, then you can do that. If you have a regular polygon like the square or an octagon or a pentagon, anything that's a regular polygon, it means all the sides, all of the bases are going to be the same length. So that means your heights are going to be the same length. Then you can just multiply times however many sides you have. But if you have an irregular polygon, meaning all the sides are different, then you're going to have to calculate each side with a different base. You should have the same height, but it would have a different base. All right, and that is all we have for lesson 120. I will see you in lesson 121.